You ever wondered how you could visualize your voice with HTML form controls? Well, today I'm going to show you how. But why? Well, this is kind of a little demo I use as an icebreaker when I speak at conferences, and the spin I put on it is about getting creative with different things available on the web platform. And a lot of my videos are going to kind of go in this direction of doing something that you probably wouldn't typically do, but you pick up a lot of little skills and tricks along the way. So let's get to it. Here we go. Let's start with an input of type range, and it's going to have a value of 0, a min of 0, and a max of 100, and a step of 1. Cool, right? And you can see this is your typical type range that you can update. You've seen them before. Let's hop to our styles, and we're going to start by declaring a custom property hue with a value of like 280, and then we're going to jump into accent color, and we're going to use HSL, and we're going to use that hue and then set a saturation and lightness. No idea what the IDE is doing, but if we hop over to our input, we can see that the accent color for our form control is now this light purple color that we set. And an interesting part here is that the color scheme auto adapts, so you can see the track has turned dark. Now, accent color is what kind of drives the demo today. So the idea being, what if you could map the input's value to a hue and have have the accent color update as you update the control? How could we do that? Let's hop to some scripts and see how that might work. Now we're in script town, so we need to grab our input, and we can do that with document.query selector and grabbing the input, and then that's going to need an event listener. So we can use add event listener, and we'll use the input event, and we'll just have like an update function that we use, and then that's our update function. Inside our update function is where we want to take the input's value and map that to a hue. Now this is the reason we're using HSL, because hue works on a wheel. It's like 0 to 360 gives you all the different colors. And we can take our 0 to 100 value and map that against a hue range. Now let's start with 0 to 360, which is the entire wheel. And for that, we're going to need a mapping function. And here's one I built earlier. So the idea is you put in the ranges that you want, and it gives you a function that you can use. Now, we could use this, but because we're going to be using GreenSock today, because I'm going to be doing some animation stuff, I actually have that package available, and we can use GreenSock's utility functions. And they actually have one already called map range, which does exactly this. Let's start by creating our hue mapping function with GreenSock, and that's going to be gsap.utils.map range, and we know our value is 0 to 100, and we're going to do 0 to 360. Now this is an interesting part because we can take the range and put it in, and we could also read the input's min and max value there, but because we know them, we're just going to do that. And then inside our update, we just need to do input.style.setProperty, and then we're going to set the hue which we're using, but then we're going to take our mapping function and just pass in the current value. So to do that, we're going to have to pass it as an integer, and then we'll do input.value 10. And before we do anything, let's run update. So if we hop over to our demo, we can see that this actually works. Now we drag it, and we can see that that accent color is changing as we update the input, which is pretty cool. It's a pretty cool effect in itself. But this is where the creativity part comes from. Now we can map a value to a hue range. What if that hue range is, say, green and red? And it kind of reminds me of equalizer bars, and that's kind of why I made this demo, why I kind of went along that path. I'm thinking, how could I take audio input from, say, a microphone and map that to a value, which then updates the accent color and kind of looks like an equalizer bar? It's kind of a cool little challenge. So we're going to do that, but first we need to worry about making these inputs look like EQ bars, so we're going to have to flip them on their side, maybe square them off, get rid of the thumb, lay them out nicely. So let's hop back in and do the styling. Now we're going to have to adjust our markup for however many bars we're going to want to use, and I'm going to go with 12, and arguably we probably want a container, and then like 12 bars, and then within each we'll just do our input type equals range. I'm using Emmet to do this, by the way, if you're wondering. It kind of speeds up writing HTML. So if we do that, now we have our bars and inputs all ready. Now we can see these all in the browser, and now they're ready for some styles. And now for those styles, so our EQ container, probably use something like display grid, and then grid auto flow column. Now this is the reason why we use the wrapper around each input, because then I can set a width on these and say it's something like 40 pixels. And if we look in the browser, you can see that the inputs are overlapping their grid cells, which is exactly what we want, because then we're going to rotate the inputs. And to do that, we're just going to hop in and we're going to do a little translate. So we're going to translate them across 50%, and then we're going to rotate them minus 90 degrees using individual transform properties. And there we go. That's now kind of what our EQ bars would look like, but we want to thicken them up a little bit. Now, tracks and things are kind of not ideal to style, and we want to keep hold of the accent color, so we're just going to scale them up by 2. To make them a little bit shorter, we can just adjust the width. So if I said width 100 pixels, that will like shorten them a little bit. Now the last piece is going to be getting rid of those pesky little thumb handles, and to do that we can use some browser specific prefixes. So we have WebKit slider thumb, and we're going to set that to opacity 0, and then we have, I believe it's Moz range thumb, and we're going to set that to opacity 0 too. And we hop over, cool, there are all our thumb handles gone, and now we're ready to get the input from this and show it over here. Let's hop into Scriptown and you'll see things have changed. We now have this config object which we're going to use for our audio analyzer and our animation of the bars, and we have this gen inputs function which generates the markup for us, the bars and the inputs that go within them. This is because we're going to define the amount of bars inside our JavaScript, and we don't want to hop between the markup and the JavaScript to keep updating it every time we change our mind. So we're basing it on the FFT. We won't dive deep into audio terminology, but the FFT is something like the fast Fourier transform. I'll leave a link below to some things to go read up on if you want to dive deep. But essentially that's what's happening. We're saying, right, take the FFT, half it, and create that amount of bars. And then we're setting in GreenSock, because we're using GreenSock to do the animations, we're setting the FPS based on the config too. And this is kind of just the boilerplate to get us going. And now we've got some boilerplate. Let's create a GreenSock timeline that animates our inputs randomly to start with. So gsap.timeline, and then the trick is that we're going to use the ticker functionality. So gsap.ticker.add, and we're going to create an update function that will run on every frame of the ticker. Our update function will try and run 24 times a second because the FPS has been set to 24 via our config. And in here, we're going to loop over our inputs and animate each one randomly for now. So we can do inputs.forEach, and then we'll do gsap.toInput, and then we will do a value, and we will also set the hue at the same time. Now I want to create a value that is random, so I can use gsap.utils.random and pick a random number between 0 and 100, and I want to pass that in to the hueMapper function we defined earlier. So hueMapper and then value. Now if we run that and hop into a browser, you can see that all the inputs are animating, because we're using GreenSock to tween to a random value and also animating that custom property value that we're using the hueMapper function for. So now we know how to animate the inputs on each frame. The last piece is hooking it up to the input from the microphone. Let's remove the animation code, but we'll keep the timeline because we'll use that. And I have some boilerplate code set up here ready to connect to the microphone. In order to connect to the microphone, you'll need to use the getUserMedia function, and then once you've connected, you get the stream from that, you can pass it into an audio context to analyze it. This code is a little bit boilerplatey, but the idea is that you create an audio context, Set the FFT size. Remember, that defines the amount of bars we're showing because we're defining it through a shared config. And then you grab a media stream source, and then you set up a data array that we can put the audio data into, and then you connect the source to the analyzer. I'll leave some links below if you really want to dive into it, but I'm trying to keep this as easy to follow as possible. So once you've done that, we're going to use our ticker again, and then we're going to add an update function. And each time, each frame, the idea is that you get some data from the analyzer and populate the data array with it, and then you can visualize it. If we run that and hop into a browser and open DevTools, you can see that the array is constantly being updated with new values based on what's coming through my microphone, which is pretty cool. So we're using get byte frequency data, and that gives you a value for each bar between 0 and 255. Now the alternative to this is get byte time domain data, and that acts slightly differently. That kind of acts like an oscilloscope, which might be quite useful for this, but you'd have to map the values around that because it kind of acts like it goes from -1 to 1, where 128 would be around 0, so you'd have to map it out. But let's go with get byte frequency data for now, and then we'll change it later and you can see the difference. As we update the data array with our frequency data, which is ideal for our equalizer bars, we're going to take that array and we're going to map it. So we're going to do a little spread, and then we're going to take each frequency and we're going to map that to a value and then return an object with the hue and the value. So let's say const value equals gsap.utils.map range, and I know the input is going to be 0 to 255, and I'm going to map it to 0, 100. And yes, you could refactor that utils.map range out and turn it into like a frequency mapping function. But for now, we're just going to return an object, and we're going to return the value, and we're going to return a hue, which is going to be the hue mapper function, and that's going to take the value, third time's the charm. Now we have all the data we need, we can animate the inputs with that data. So we grab our timeline, and we're going to do a 2, and we're going to animate all of the inputs. And then we're going to use function-based values for the properties we need to animate. So let's start with the value. And the value, we can take the index of the input, and we know that it's going to be bars index dot value. So bars is our mapped object array, and we're just going to take the value of the index. So, and then we can do the same for the hue. So another function-based value. Let's get a space in there. Bars index dot hue, and that doesn't look great. These bars aren't really moving that quickly, so let's make a couple of changes. First, I'm going to set our configured FPS to 60, so a bit higher hopefully, and things should hopefully improve. So if we go back, things are moving, but it's still really slow. It's not 60 FPS. That's because we need to actually set where our little tweens are happening in the timeline. So first thing I'm going to do is set the duration. I'm just going to set that to 0.1, and that will make a little bit of a difference. But the trick is actually the second parameter, which tells you where to put that tween in the timeline. And the trick here is that we can use the ticker.frame, and then we can times that by 1 over the config.fps, and that will place each tween perfectly in the timeline where we want it. Now hop into the browser, and this looks way better. It's smooth, it's fast, it's updating based on the voice input coming through the microphone, and yeah, it works as expected. The only thing is that it's clear to see that some frequencies get picked up a lot more than others, but you can test it with different things. For example, the click of my pen picks up different frequencies, which is kind of to be expected. But this is where get byte time domain data kind of looks a little bit more interesting on stage because it uses everything with the oscilloscope. So let's see what that would look like and how we could map that. But first, let's get this range mapped so it goes from red to green as we initially intended. All we need to do for that is adjust our hue mapper. So we have the input 0 to 100, and we could say, hey, at the bottom it's going to be like 140, which is kind of a greenish hue, and at the top end it's 10, which would be like a red hue. Now if we jump back over, we can see that at the top end it's red and at the bottom end it's green. And you totally want to tweak this to your taste. So you can jump back in the CSS and maybe you want to bump the saturation up, take the lightness down a little bit. And then if we jump back over, things are a little bit darker now. And that kind of looks all right, but let's see what get byte time domain data would look like. Now things are going to look a little bit wilder. I'm going to start by duplicating this line and we're going to comment the original one out. And then I'm just going to swap this for time domain data. Now with time domain data, you can see that all the bars are just kind of hanging around in the middle. And that's because of the oscilloscope kind of nature. It's used for waveforms. It goes from 1 to -1. 128 is around the 0 mark, and that's why it's hanging out in the middle. Now for us to make this look a little bit more exciting, we can take that value and map it and then put it back in and make it a bit more exciting to look at. Now to do this, we're going to create a new value called pre that takes the frequency and turns it into something more like the value we'd get from get byte frequency data. So to do that, we're going to do gsap.utils.mapRange, and we're going to say 0 to 10, 0 to 255, and then the value we're going to pass in is going to be 1 minus, and then we're going to take the frequency and divide that by 128, and then we're going to times the whole bunch by 100, and then we're going to pass that into the value. Now if we jump across and have a look at that, we can see that it's pretty wild, like it's jumping all over the place, but you can see the hue is getting updated. The only thing is, if you really shout into it, you can actually see that the hue is getting updated out of bounds. So there's a couple of little things we need to change here that will make this look not so wild, but still exciting. So let's hop back in. And the first thing is, I want to make sure that this hue is clamped. So I'm going to use our gsap utility clamp, and I'm going to clamp it between like 10 and 130 for the hue to make sure. So if I clamp that, and then the other thing I want to do is set the frame rate a little bit lower. So go back to 24. And now if we jump back into the browser, we can see that this actually looks a lot more manageable. And it's kind of, I don't know, a little bit more exciting. I think the issue is that when you use frequency data or time domain data, you kind of want something that kind of shows a bit more across the board. I don't know, for me, I just wanted to see something a bit more symmetrical. So I tend to show get byte time domain data when I'm on stage, but frequency data is the easier one to show off. And you could obviously tweak these animations and do the mappings how you see fit. This is just one way I've messed around with it. I'm not an audio engineer by any means, full disclaimer. But yeah, this kind of works. It's kind of fun. And then I can just switch back. So if we go back into the code, we can just take that out, swap that back to using frequency, jump back to that one, turn it on. But this kind of looks a little bit slow at 24 frames per second. It doesn't look that great. So we can switch that back to use 60, and GreenSock will try and use whatever the max it can up to 60. And then, yeah, this looks way better. So from just messing around with one property, CSS accent color, you can go on this whole journey and try and do something completely different. Visualizing audio using HTML form controls. You can totally tweak the animations, tweak the mappings, do something different. Maybe you want to make them scale up, make them bigger. You know, you can go all different paths with this, but you'll learn different tricks along the way. So yeah, I hope you learned something from this video. Let me know what you think below. You're the ones that drive the content direction, and stay awesome. See ya.